know that we have creative start, that some people are getting out of there a little bit later than others, but that is okay. We're going to look at that image on the start slide a lot as we go through the next few units. It'll probably be our start slide for 2 or 3 days because it's got a lot of really good information on there. But for today, we want to review the 1.5 notes before we dive far into Chapter 2. So we are back in 1.5. We did I know we did the lawn problem. Did we do the board to the tile? No. Yeah, so I know that I left you guys, and actually, for the record, my sub was supposed to be Mr. Hull, and he, like, Hull, Jimmy, the guy who's been here before, kind of militaristic dude. He used to be in the military. So I like him a lot. He was supposed to be my sub, and then they changed it up, and then you ended up with the other sub. So I have no idea how mathy or not your guest teacher was yesterday. So, especially realizing that it wasn't going to be Jimmy, I just figured I'd let you guys, like, do work on your own, work with each other, and see how far you could get. So, I want you guys explaining to me what you did to get through these problems. So, what's the biggest, like, alarm or alert or, like, thing that you need to identify first in this problem before we can start really solving the problem? There's something we need to be very aware of. Sam, your hand shot up. I have to change the units to be the same. So I can't compare feet to yards because there's already a discrepancy between feet and yards. Now, is it easier to go from feet to yards or from yards to feet? Yards to feet, it's easier to go to the smaller unit. So we need to convert our 1/4 of a yard and 1/6 of a yard to feet. Need a pencil, I will give you one. And I have a sharpener as well. So, how do I go from yards to feet? What's my conversion? Monis?
3 feet is a yard.
Yeah, 3 feet equals 1 yard, so I can really multiply these by 3. So this gives me 3/4 of a foot. And this would give me 3/6 or half of a foot. So those are now going to be the values that I use to compare. So when now this is where it gets dangerous. Anyone pay attention to this? Area of the board to area of the tile. How do I figure out the area of a rectangle? Jeremiah?
Multiply the length by the width?
Multiply the length by the width, or the width by the height, or the height by the length, or whatever 2 dimensions you have.
Yeah.
The name of what the dimensions are kind of starts to be really flexible. Because in geometry, if I have a width, a height, and a length, I can turn this any way I want. So length, width, and height don't really matter how we name it. It's just the dimensions that we have. So, to find the area of the tile, I'll do 1/4 times 1/6, and we know that multiplication just works straight across. So this becomes, that looks a little sloppy, 1/24 feet squared. Now we could have also turned this into inches if you wanted to make your life really easy. But if you didn't, we got 1/24 for my tile. Yeah, you can convert to as long as what you've done mathematically holds up. And your answer should still be the same. Whatever you got for inches should be the same as what we end up getting here. 3/4 times 1/2, and if you didn't do this work, I would do it now, becomes 3/8 feet squared. And remember, that square only affects the unit, does not have any effect on the number. So then, when I compare tile to board, that tells me how do I set up my division. Andrew?
Put the tile first, then the board.
So I'm going to do 1/24 compared to or divided by 3/8. I then, to deal with the fact that I have a fraction divided by a fraction, Elena? Keep change flip. I saw it on your face. You're like, I can say the answer if he really wants me to. No!
Cross
Cross-simplify.
You can cross-reduce, cross-cancel, cross-simplify. You can never cross-multiply unless there's a proportion.
I'm at cross reduce.
Yeah, so be careful with what you say. So we do 1/24 times 8/3. We can cross-reduce here if you want. So those could both divide by 8 and make my life easier. But if we don't cross-reduce, I multiply straight through and I get 8/72. And here's the thing. I could have divided by 8 here, or I divide by 8 here. Either way, I get 1. Sorry, not 6. What's 72 divided by 8? 9, sorry. Got goofed up in my head.
You were just testing us.
Sometimes, yes, but that was just I didn't think. So the ratio is 1 to 9. 1 to 9. So the area, 1 tile to the area 9, the board is essentially 9 times the size of the tile. So, Whitney, if we want to say how many tiles will fit on the board,
I just wanted to say, I'll do that one, but I just wanted to say for B, we forgot to simplify, so it's 654 still be 1/9.
for B, where?
The one we just did for the ratio. Instead of 1 to 9, could 654 still be it? We just forgot
If you divide by 6, yeah, it'd still be 1/9.
Okay.
Yeah, 6/54 is 1/9.
For C, do you want me to just tell you what I got?
Yeah.
We got 9 tiles.
Yeah. If your ratio is 1 to 9, that means that 9 tiles will fit on that board if you're just practicing your tiling.
Did you put it at 9 to 1?
So that would be if we took the area of the board to the area of the tile, if we flipped the ratio around, then we see 9 to 1, which tells you 9 tiles fit on one board, which essentially gives you the answer of C. Now 1 to 9 does the same thing. The order's just kind of backwards, but if you can analyze it, you can still get the same result. Yeah, because it says the same thing regardless of which way I write the ratio. Jeremiah?
I still don't, I don't know what the final answer for A and B is. I got what the one for C is, but...
Sorry. A, I kind of skipped right past. My apologies, because I dove into finding the area. Ratio of length of the tile to length of the board. So, my bad. Totally skipped this. Length of the tile was 1/4 of a foot. Length of the board, we found out was 3/4 of a foot. We already did that conversion. So we just do 1/4 compared to 3/4. I can keep change flip that, which becomes 1/4 times 4/3. The 4 on top and bottom will cancel. Or if I compute and then reduce, I will get 1 to 3, which tells you this length 1 will actually fit on here 3 times. So we have 1 tile, 2 tile, and 3 tiles. And then actually, if you want to draw the picture, that's approximately what it would look like. You could stack 3 tiles tall, and you could run 3 tiles long. So 3 by 3, you end up with 9 tiles on your board. So the length ratios should have come out to be 1 to 3. Did we have any big issues yesterday when you solved through that?
Yes.
So what were your issues? The area?
Yeah.
So part A, you should have totally been able to find part A.
Yeah, that was.
Part A should have not given you any issue. Whitney?
It was the easiest one if you convert to inches.
Yeah.
It was really super easy.
If things seem difficult, keep going to smaller units. The smallest units will give you the biggest numbers, but that's easier to work with than little tiny numbers. Yeah.
What I did was I would do the easier side first. I did the back side first instead of doing the front side first. It was easier.
Yeah, sometimes the questions kind of vary. And because this was the last lesson of the unit, it just kind of wraps everything up together.
This seems similar to unit rates.
Yeah, it's very similar. All of the ratios and rates are very similar to each other. So ratio, area of the image on the screen to the print. So first, I see inches and feet. So we're going to want to convert what to what? If I see that I'm using the labels inches and feet,
Wouldn't
Yes. So really what I'm asking is what's easier to work with? Is it easier to convert 1.5 inches into feet? Or is it easier to convert half a foot into inches? Ellie, do you know? Easier to go from feet to inches or inches to feet?
Yeah, sorry, I'm just double checking. It's easier to go from feet to inches.
Feet to inches, right? Always easier to go smaller unit. So let's somewhere, and on your paper you probably are going to write it somewhere different, notate that we're talking about the print. The print was half a foot and 1/3 of a foot. But to convert to inches, we know there are 12 inches in a foot. So we multiply by 12. We get 12 over 2, which is 6 inches, or 12 over 3, which is 4 inches. There are 12 inches in each foot. So if I set this up, I really have 1/2 and the label stays on top. So our conversion factor would actually be inches on top, feet on bottom, and it converts out and cancels the units that we don't want.
For the length and width.
Because we are taking these feet and converting them into inches.
I
Yeah.
feel like when you do this stuff, like you make it more complicated than it actually is.
I'm
Like,
showing
it-
you
it
the
just
mathematical
happens.
process.
Yeah, but it just makes it more complicated. Like we would understand.
But
it
what
better
if you were given an 1/18 of a foot instead of a half? I know that this is an easy value to work with, but what if you were given 1/7 of a foot? Can you calculate a 1/7 of 12 real easily?
No.
No. That's why you want to understand the
But, like, just
process,
for the easy ones, like
but they won't all be easy. So if you have the work written out for the easy problems, when you get to the hard ones, you can refer back to the easy ones, and it will make sense. I agree with you that a lot of times I make it look more complicated than it needs to be, but it's so it all makes sense. I know you know a foot is 12 inches. What's half of 12? 6. But if this wasn't half, if it was something really awkward, then you'd be happy that we know this process. So I really have 6 inches by 4 inches. So now we need to find the areas. How do I find the area of my screen? Dom?
You should just do like 6 times 4.
That's the print.
Or for the screen, wouldn't you just do half or? Oh wait, wouldn't you want to convert your 1.5 inches to just an improper fraction?
So this 1.5 I can really think of as 3 halves, right? So if I want to, I can tell myself, well, this really equals 3 halves. How do I find the area of the screen? Well, somebody already told us length times width. I've got a length of 3 halves, and here it's really a height of 1. What would 3 halves times 1 give me? 3 halves. So my screen area equals 3 halves, and you have to have a unit on here, and it has to be inches squared. Because I did inches times inches, I get inches squared. And for my print area up here, somebody already said it. We do the 6 times 4 because they thought we were doing print first. So if I do 6 times 4, I get 24 inches squared. And now I have to compare screen to print. So we set up screen 3 halves compared to the print, which is 24. So what do I do with my 24? Make it a fraction by putting a 1 in the denominator. Then we can keep change, flip it. I could cross reduce if that process makes sense. Solomon, are you getting this written down? Because I bet if I come to your paper, you don't have this written down.
I have it written down.
Okay. So, if I cross reduce, can somebody explain the cross reduction process again? Because some of us know it, some of us don't. Evie?
So you take two numbers that have the same
Yeah, we look for a common factor of a number. So one of the numbers that can multiply up to make it. 3 and 24 both share a factor of 3. So either I cross-reduce right now, or I have to reduce at the end. Either way is the same. So I could divide this by 3 and divide that by 3. So this numerator would really become 1, and this denominator would really become 8. So I have 1 times 1 equals 1. 2 times 8 equals 16. If you didn't cross-reduce, because you don't have to, you would have gotten 3 over 48. 3 over 48 is equal to 1/16. So you don't need to cross-reduce. You don't ever actually need to. But it makes your life easier. Like I said, my goal here is to make your life easier. So we get 1 to 16, which means the print is what? Sam? 16 times as large as the screen. So when I go to your guys' games and I'm taking pictures on that digital camera, I'm looking at a really tiny screen. And actually, our camera, I have to look through the viewfinder. So I'm literally looking at a tiny little box. But then when we put it on the computer screen, picture looks a whole lot better because everything's a lot bigger, crisper, clear, all that stuff. Yeah, so if you guys have events that you want us to come to and get pictures at, let us know. Yeah, we're going to jump around. So this, we do the exact same thing. We just do miles per hour. So, at the risk of us not getting as far as we want to, does anybody know how to do this? Is anyone really confident with this problem? Okay, so that tells me something to begin with.
He said he is.
Yeah, but if he's going to say it to you, that's different than saying it out loud. So, I guess let's talk about this problem. The first most important thing that we need here, out to the left.
I'm not confident about it, but I just have something to say about it.
Okay.
It really doesn't make any sense that it takes your dog to run 18 minutes to get there and then 20 minutes to run, and then 24 minutes to run back if you're running both times.
So, think about it. If Mr. Smith says run as fast as you can out to the tree line, all the way at the end of Perry Park, and then back, which way do you think you'd be running faster? On the way there or on the way back?
On the way back.
On the way there, right? Because you have more energy. So it's going to take you longer to get back from the tree line than it did to get there. Because now you're tired, right? So, dirt, D equals rate times time, or D equals RT, means distance equals rate times time. This is one of the most important mathematical formulas. Dude, just stand. You're either sitting at a desk or you're standing. Get your legs out of there. You've made this too much of a distraction. You're either sitting at a desk or you're standing back there. You're not both. If you'd like to sit, there are ample chairs. What do we normally use this for? Distance equals rate times time. Honest?
Finding the distance.
Sometimes finding the distance. Jeremiah?
Calculating how long it'll take you to get somewhere.
When I go on Google Maps and I tell it I want to drive to Mount Pleasant, South Carolina, and it tells me it's going to take me 9 hours and 25 minutes, it didn't just make that up. It looks at the distance you need to travel. Now, Google, though, makes an assumption. What do they assume about my trip that I haven't taken yet? Julian?
How much time is it going to take to get there?
No, that's what they're predicting, but they make an assumption to make that prediction. Noah?
How many times you stop?
Not even that. That's in the algorithm. That's part of their calculation, but there's how many times I stop does not directly play into this formula. You haven't Ozzy, we haven't heard much from you today.
Do they count your gas?
I mean, if I tell, like, there are parts of Google where you could have it calculate how much gas am I going to need, yada, yada, yada. Where do I need to stop? Jeremiah?
How much traffic?
Well, it runs the analytics on that too, because think about this formula. I know my distance. Sean?
How fast you're going.
It makes an assumption of my rate.
You're going to
It assumes that I'm traveling approximately the speed limit. Which is, if you ever hear anybody, your parents, or as you guys start to drive, they're like, oh, I beat Google. Or I beat the S, means you drove faster and took less time than what it predicted. But sometimes its prediction is wrong because you get stuck in traffic. So the speed limit is 60 miles an hour, but I'm in traffic going 20. It's now going to take me more time because my rate has gotten smaller or less. So, on Monday, you and your dog run to the park. What is this 2 1/4 miles in my formula? What would that be?
your rate.
Is that a rate?
That's your distance.
That is our distance. Above it, put a
I
D.
was looking at something else.
Above it, put a D.
I'm special. I'm special.
It takes your dog 18 minutes to run there. What would that be? Our time. Above that, put a T.
Ooh, I know.
The 24 minutes is also a time, but that's going to be a different time.
Okay, what's my 2%?
Dude, it's 2 1/4 miles. When's the last time you ran 2 1/4 miles?
Yesterday.
With the
That was a mile.
Oh, never mind.
Yeah. Talk to me after your second mile, then let's talk about speed. So, hold up. On Tuesday, no wait, where did this 4 1/2 come from?
That's not. It's near. Oh, it's the entire. That's the entire.
Say it louder, Dom.
It's the entire distance.
If this is how far the park is from your house, this 4 1/2, you can't just live at the park. So this is our entire distance.
Dang. This person is confident.
So this was actually, if I was you, I might change it. That's really half of the distance.
18 minutes, 2 1/4 mile in 18 minutes. That's impressive.
So, hold up. We have a lot of stuff to figure out here. We need to now compare Monday with Tuesday. So, I need you on your paper to somewhere set up, like make a little division that we're going to compare Monday to Tuesday. And we're going to use 2 different formulas, actually. Because this is all your Monday info. And then we have your Tuesday info. So I'm going to do Monday in blue. Because I'm probably going to run out of space because I write bigger than you guys.
Use logic.
On Monday, what's my total distance?
2.5 miles.
4 1/2, right? Because I went to the park and back. What is my total time?
42 minutes.
Ellie?
42 minutes.
I add these both up and get 42 minutes.
Do you think that kid could beat you in a race because he ran 2.5?
Well, let's calculate what his speed is, and I know what I run at approximately.
He could be.
Set up your D equals RT formula. How do we always talk about speed? Whitney?
I just wanted to say something. You said 4 1/2 miles. It's 4 1/4 miles.
No, it's not. It's 2 1/4. When we double it, becomes 4 1/2. Because this was the distance to get there. So think about it. So let's say I'm going to your desk. I take 1 step, forget that first little step, 2 steps, and 1/4 of a step. So now to go back, I take 1/4 of a step, then another step, and another step. So I took 4 total steps, and 2 quarters make a half. So, do I have my, back to the question I had asked. How do we always talk about speed?
Miles per hour.
Miles per
Minute.
hour, right? Well, Snapple, I have minutes. I want hours. Here's that whole conversion process.
Not legal.
Guys, knock off the side conversations so I can quit playing with your fruit, man. Because I bet you don't have all this written down.
No, I do.
42 minutes. To convert into hours, put your 42 over 1. I want to get rid of minutes, so I put that on the bottom, and I put hours on the top. 1 hour is how many minutes?
60.
So yes, Whitney, I just made this look more complicated than it needs to be. All we're really doing is taking your minutes and dividing by 60. But this is why we do it. So 42 divided by 60 would reduce. Is there a nice fraction, or is it? Yeah, it's 0.7.
I sensed it.
So that is 7/10. Hey, Star Wars is on. Can we get over it? If it's happening in a class, you will see it.
Yes.
I need your attention here right now. You can worry about Star Wars when you're in that class. Now that we've wasted a minute, can I move on?
Yes.
This is now, and I barely have space to fit it in, hours. So make sure you put a label on that as hours. Now I can plug values into my formula. The biggest mistake people make here is trying to use minutes for time. You have to use hours if you want your rate in hours. And because their rate up here for Tuesday is in hours, I need my rate in hours. Now, if I had my Tuesday rate in minutes, like miles per minute, then I could use minutes here. But if you do a miles per minute calculation, do you think you'd have more than 1 or less than 1? Less. Think about how many miles you could run in a minute.
0.
Not even a mile. So you'd have a very, very small number that'd be annoying. So my distance is 4.5. Let's start plugging in. I'm going to go ahead. Actually, let's make our distance improper. We don't like mixed numbers. What's 4.5 as an improper? 9 over 2. My rate, I don't know, but I'm trying to solve for that. And my time, I know, is 7/10. Hey guys, can we focus on my class? Monica.
How does 7/10 work? Because isn't an hour like either 60 minutes or just 1 hour?
Yes, but we got 0.7 of an hour because that was 42 minutes.
Okay.
All we did was reduce the fraction, essentially. We got 42 over 60, and these could both reduce by 6. So we got 7/10, which we could write as a decimal value, or we could write as a fraction value. And there's a reason why I'm writing it as a fraction value here. Because we want to solve for rate, I need to get rid of this 7/10. And I'm doing all this so that when we get to the chapter where you have to master this, you will already have a lot of practice. How can I totally get rid of this fraction and turn it into a 1? Monza?
Divide.
I do not want to divide fractions because that process is arduous. It's very annoying. Sam?
Multiply by its reciprocal.
Multiply by its reciprocal. So on both sides, we multiply by 10 over 7. This gives me that our rate is 90 over 14. That could reduce, I'm going to go ahead and write it out this way, 90 over 14, 45 over 7. Unless 45 can reduce and divide by 7, we might as well just write this as a decimal value. Or I guess they have a mixed form.
Wait for Monday?
Yeah, this is Monday. We have not touched Tuesday yet. So we took Monday's total distance of 4.5 because they did 2 1/4 there and 2 1/4 back. Then their total time, 42 minutes. So if I divide 45 by 7, we get 6.43 if I round miles per hour. Which is bigger? 6.43 the Monday time the Monday rate, or the 6 1/4 Tuesday rate? Monday, right? Because 6 4/10 is bigger than 1/4. Because this would be 6.25 compared to 6.43. Monday was faster. Which makes sense, because if you do a workout on Monday, you might be sore on Tuesday. It's called DOMS, delayed onset muscle syndrome, or muscle soreness. So there's literally, not DOM as in our friend, but DOMS is a thing, like, so your muscles, when you work out and you actually push your muscles release something called lactic acid. And that goes into your muscles, and like it helps your muscles, but it makes you feel sore. So if you ever wake up and you're like, man, my arms feel like a ton of bricks, it's because you have a lot of lactic acid, or DOMS, delayed onset muscle soreness.
No,
There are various kinds of acid.
It's the acid in the body.
So I have relented to the fact that we will not get to 2-1 today. We'll just put 2-1 on tomorrow and start chapter 2 then. So I want you guys to try this on your own. You are currently parked 7/8 of a mile away from the football stadium. That, would it be a distance, a rate, or a time? That's a distance. You walk at a speed of 3 1/4 miles per hour. Would that be a... That's a rate, because it has a per involved. The game starts in 14 minutes. Now wait, we have distance, rate, and time? Is that time how long it takes me to walk there? No. That time is how long I have before the game starts. So do I want to use, like, which of those numbers do I want to use in my calculation? Anish? The distance and the rate, because this time is not actually the time of my situation. I need to solve for the time in my situation. So we want to set up your dirt formula, fill in for the variables, and then solve. But realize there's going to be something interesting about the time that you end up calculating. Try this on your own. You can work with partners. So guys, when I mean on your own, I mean without my help. So you can always, when I say on your own, you can talk with partners as long as it's about the math. You want to solve for your time. Can I change the order of multiplication?
I think so.
What property allows me to do that?
Commutative.
Commutative. To commute means to move. Commutative property. So how did you know to do what you did? Why? How do you know that to find time you do this? What? Okay, so what are you dividing? So if I were to ask you time is blank, like what division did you set up? Like what is divided by what? You have distance divided by rate. So essentially you're saying time is d divided by r. Yes, what you did is right. I'm trying to get you to understand how you know to do this. So I want to pause for just a moment, whether or not you have your answer. And this is why I wrote this in 2 different places. I can plug into my formula and realize that what I'm trying to solve for is connected with something else. Or I could come over here and say what I'm trying to solve for is connected to something else. But right now, this something else isn't yet a number, so it's easier to work with. how is rate connected with time, or time connected with rate, depending on which way you want to look at it. And I'm going to go to Jeremiah since he already had this solved. I'm just pushing him to explain why he did what he did, so I'm kind of picking on him, but I know he can take it. So Jeremiah, how are time and rate connected here? What mathematical operation?
You would use time to find the rate, I guess. I don't know.
You're thinking too hard. Listen to what I'm asking. How are these two variables connected? What math holds them together? We said distance equals rate, time. Multiplication, right? How do we break apart multiplication? Division. So I could over here, before I ever start the problem, just say, oh, if I want to solve for time, get rid of rate. So really, these will cancel each other, and I could make a new formula that tells me time is distance divided by rate. So when I went back and I looked at Jeremiah's paper, he immediately had distance divided by rate set up on his paper, but couldn't explain to me why he did it. He said, I just learned it in 6th grade. I need you guys to understand why you're doing things. If we go back to the dirt formula, distance equals rate times time, I can solve for time by dividing by rate, which is how I get to here. Gravity works. So, that's one route, and I'm actually going to go to Jeremiah for that solution. But there's another route. Other Jeremiah, do you have a question?
Yeah, will you go over that process again? I'm a bit confused.
So, we looked at the fact that distance equals rate times time. We know that formula, we accept it. Miles per hour times hours will give you miles. We could work this all kinds of different ways. To solve for only time, like the time it takes you to get somewhere, we would want to get rid of rate, because we want to solve for time. We want it to be by itself. So to get it by itself, I look at they're held together with multiplication, which kind of looks like a heart right now. So how do I break them up? Divide, because it's the opposite or the inverse operation. So I divide by rate because anytime I take a number divided by itself, what's a number divided by itself? 1. Not 0, it's 1. So this right side becomes 1t. The left side is just d divided by r, so I see to solve for time, I take distance divided by rate.
So isn't that 7/8 divided by 3 and 1/4?
So I can take my distance divided by, and actually my rate I would make improper if I was going to do that. 13/4. That will solve out to give me my time, which is what Jeremiah did.
Oh, okay.
Other Jeremiah.
Yeah, okay.
So, if I was going to go solve this one first, but we'll come over here and solve this in a second. If I use our new formula, which guys, I would put this in your notes somewhere very obvious. Anytime you want to solve for time, you can just take the distance divided by the rate. I would highlight that. I'd put stars next to it. That's an important formula. It's a related formula to our distance formula. I could then keep, change, flip. 7/8 times 4/13. I could cross reduce if I want to. If you understand that process, sweet. If you do not understand that process, this would become 28 over 80, 104. 80 plus 24 gives me 104. I broke up the multiplication, 8 times 10, then 8 times 3. Then that reduces, but hang on, we'll get to that reduction in a second. If I had cross-reduced here, 4 and 8 both share a factor of, Evie? 4. So I can divide this by 4, it becomes 1. I divide this by 4, it becomes 2. 7 times 1 gives me 7. 2 times 13 gets me 26. That is my reduced form. But wait, that's what? 7/26? That's time?
Takes a 7/26 of an hour?
Of an hour. Because your rate was in hours, the time you'll get is in hours. So how do I turn hours back into minutes? Ellie? Not divide by 60. To go down, we multiply by the 60. So 7/26 times 60 gives me 16.15 minutes. Will you make it to the game in time? Nope. Now the other way that we can do this, if you set it right in the formula and go to solve from there. And this is what we're going to do in the equation solving chapter that we have. I would recognize, I want to get t by itself. How do I do that? Multiply by the reciprocal. So I multiply by 4/13. Multiply by 4/13. Hey, look, it's the same work I just did. And this would come out to give you the same exact answer. Multiple right ways to get to Florida. Any preguntas? Questions? Really quick, I got a minute still. Let's just chat about the other two because we're not going to cover these. For this one, we would just set up the comparison, and actually it's easiest to derive this one and then use that to derive all of these because the larger the number is, the easier it is to work with. And we do the same comparison sort of thing here. We'll make it tomorrow. I'll change the due. If I don't change the due date before AO, remind me. Thanks, you guys. Have a wonderful day.